All right. Welcome, everyone. We'll just admit a few more from the lobby. So let's kick off. Kia ora koutou, and welcome to today's webinar on battery energy storage systems, or BESS, consultations. Ko Frida Wells Toko Ingoa. I'm in the engagement team here at the authority. So the purpose of today's webinar is to give an overview of our current work on the role of battery energy storage systems in New Zealand's power system, specifically on the two consultations on wholesale market arrangements for BESS, the code amendment proposal, and on the common quality and wholesale market arrangements for BESS and BESS-hybrids. You'll also have the opportunity to ask any questions about these consultations, which may help with your submissions. And just a reminder to please add your questions to the chat during the presentations so that we can get back to them when we get to the Q&A sessions, which we'll have two of, one after each consultation overview. And if you like a question in the chat, please like it so that we can upvote and answer the questions in that priority. So our presenters today are all from the Wholesale and Supply Policy Operations team here at the Electricity Authority. We have Claudia Gonelli, Analyst, Hamish McKinnon, Principal Analyst, and Charlie Crystal, Principal Analyst. So over to you, Claudia.
First, let's open with the karakia. Te taua mai runga, te taua mai raro, te taua mai roto, te taua mai waho. Kia tau au te maritu, te mari ora ki te katoa, humie, huie, tai kie. Thank you all, and thank you, Frida, for running us through the to who we are. I am Claudia, and I'll do quickly our housekeeping for today. So a few things to notice. Please note that we are recording this webinar and we will upload it on our website as soon as possible after we finish. As Frida said, please write in the chat any questions that you have, and remember to thumbs up or like any question that has already been asked so that we can give it priority. Also, please write in the chat if you are using AI to transcribe or take notes on this webinar for everyone's comfort. Also note that this webinar is for guidance only. We encourage you to seek your own legal advice if relevant, and we will still need to see your submissions in writing for us to be able to take them into account in our for our decision. Finally, all proposals that we are going to present in this webinar are still subject to consultation and board approval. Perfect. So just a little bit background on BESS. As we transition to a more variable and intermittent power system, the authority recognized that BESS can play a critical role in balancing out intermittent generations such as solar and wind, and it can also ensure that we have efficient investment and reduce cost across all consumers. In order to unlock the benefits that BESS can create, we want to engage with the industry to make sure that we have the right setting in place. And more recently, we have consulted on wholesale market arrangement for BESS, issue and option papers, and we published a regulatory roadmap for BESS that covers our work plan for the next couple of years. These are, of course, the feedback that we received on these two pieces of work have informed the consultations that we're going to present to you today. The consultations for today are focusing on utility scale BESS and utility scale hybrid station, with a hybrid station being a BESS that is co-located with and connected to utility scale generation station in this case. The reason why we're focusing on utility scale is because we see an increased growth in BESS in the near future and in the present, and therefore we seek to address the more immediate need with these technology, and as well as those that we see coming in the pipeline. We are releasing these two consultations as a package. We heard people feedback asking us to consider hybrid and BESS together. And so we wanted to offer our analysts an option to look at them together, but also to use stakeholders to look at them together when submitting. We've also published a paper on 5-minute pricing, which is not included on this webinar, but we are calling the feedback on it. And so now, without further ado, I'll pass the mic to Charlie Crystal, our principal analyst in the policy operation teams, to guide us through the consultation on wholesale market arrangement for battery as a code consultation. Thank you.
Thank you, Claudia. I guess just one thing to note as well, that I will just be providing an overview. So if you want to see the full detail of the proposals, you will need to read the papers. Could we please go to the next slide? So just as a quick introduction, we are proposing amendments to the Electricity Industry Participation Code, or Code for short, to make 5 broad changes. To require BESS to be dispatchable by the system operator when charging, to align with their requirements when discharging. To move to single offer forms, incorporate both the charging and discharging components. To align trading rules across charging and discharging states and between distribution and grid-connected BESS. To enable BESS to trade at their full capacity and introduce state of charge constraints in the market system to ensure scheduling and dispatch is feasible given the amount of energy stored in the battery. But because that will require software changes for the system operator and therefore take some time to implement, we're proposing an interim change to enable BESS owners to trade based on their expected capability, accounting for state of charge limitations in their trades, and to update their trade quantities after gate closure if their expected capability changes. I will now go into each of these proposals in more detail. Next slide, please. So under the existing rules, large BESS are required to be dispatchable when discharging, i.e. when operating as a generator, but are not required to be dispatchable when charging, i.e. when operating as a load. However, BESS are highly controllable assets and therefore able to follow dispatch instructions. We are proposing that BESS have the same obligations when charging as they do when discharging. We consider this will improve the system operator's ability to manage the power system, leading to a more reliable supply of electricity to consumers. It will also lead to more efficient price signals, as the cost of charging would be accounted for in price formation. In turn, this would lead to more efficient investments in new generation and BESS, leading to more affordable electricity in the long run. Next slide, please. So how will this work? The requirements would differ depending on size and whether the BESS was connected to the transmission grid or the distribution network. If directly connected to the transmission grid and greater than 10 megawatts, BESS would need to submit dispatchable bids. If directly connected to the grid and less than or equal to 10 megawatts, BESS would need to submit consumption information in a form reasonably required by the system operator. For BESS greater than 10 megawatts and connected to a distribution network, the system operator may require them to either submit dispatchable bids or provide information regarding their intended consumption in some other form agreed with the system operator. The system operator would have to give 20 days notice of these new requirements. BESS would also no longer be dispatch-capable load stations under the code. This means BESS owners would no longer have to apply to be dispatchable and wouldn't be able to choose on a period-by-period basis whether to submit dispatchable or non-dispatchable bids. Next slide, please. Now to our next proposal. The existing arrangements don't recognise BESS as a single entity that is both a generator and a load and can provide both interruptible load and generation reserve to help the system operator manage sudden and unexpected losses of generation. Under the existing arrangements, BESS are required to submit offers for their discharging component and bids for their charging component. They are also required to submit separate offers for interruptible load and generation reserve. This can create unnecessary system complexity. We're proposing a single form with separate components for bids and offers, and a single form with separate components for interruptible load and generation reserve. Next slide, please. This would allow for simpler integration of enhancements to the system operator's tools. For example, to enable greater participation in multiple frequency keeping and future ancillary services. The system operator is also implementing a fix to the physically impossible dispatches problem we described in our issues and options paper. This will mean BESS won't be dispatched to charge and discharge at the same time. The fix is due to come into effect later this month. We are also currently working with the system operator to consider upgrading their tools to enable full participation by BESS in the multiple frequency keeping market. Our proposal would help enable these changes. Next slide, please. The system operator's tools currently only allow for generators to offer into the MFK market. They offer a megawatt band indicating how much they are willing to deviate up or down from their dispatch energy set point. The system operator then constrains energy dispatch to ensure each BESS or each generator has room at the top and bottom of their range to meet their cleared band requirements. The left-hand side diagram shows, as the grey area, the levels of energy dispatch BESS can currently operate at. The right-hand side diagram shows, as the grey area, the levels of dispatch BESS could operate at in the future if tool changes were made to enable it. As you can see, compared to the current state, this would mean being able to provide frequency keeping when dispatched to charge, as well as when dispatched at low output levels. Next slide, please. So just some details of how the new bid and offer form would work. Currently, there are 10 bands, also known as tranches, in the current bid forms and 5 in the current offer forms. A band specifies an amount of electricity the load or generator is willing to purchase or sell at a specified price. We are proposing that the best trade form includes 10 bid tranches and 10 offered tranches. We considered that this should be sufficient to account for the different opportunity costs associated with different states of charge and the uncertainty of future prices. But we are interested to hear stakeholders' view on this, whether the number is unnecessarily high or if more tranches are required. Generators are required to submit a maximum ramp rate in their offer to ensure the system operator can appropriately limit changes in dispatch to what the generator can achieve over the 5-minute dispatch horizon. We are proposing BESS would not have to submit maximum ramp rates, as we expect all BESS can operate quickly enough to change from 0 to full output or vice versa within 5 minutes. Next slide, please. So our next 3 proposals relate to gate closure arrangements. The primary purpose of gate closure arrangements is to provide the system operator with some certainty as to what the future power system will look like. This enables them to assess power system risks and prepare mitigations ahead of dispatch. For example, it enables them to build accurate transmission constraints if they know the geographical distribution of generation and loads. When we talk about gate closure arrangements, we mean the rules relating to, first, what the bid or offer must look like at gate closure. Second, what the gate closure period is, in other words, how long before the start of the trading period that bids and offers must be locked down. This is typically 1 hour for most types of bids and offers. And third, what are the requirements and permissions for changing bids and offers after gate closure? For most generators and loads required to submit bids, the intent of the code provisions is that bid and offer quantities are only changed after gate closure in rare circumstances. The exception to this rule is intermittent generation like solar and wind farms, for which effective offer quantities must be updated to reflect changing weather conditions. After gate closure, bid or offer prices cannot be changed. This enables the system operator to understand how price-sensitive demand in generation might respond to variations in intermittent generation and demand from what is expected at gate closure. Next slide, please. So what are the issues with the existing arrangements? First, the rules for bids differ from those for offers, particularly for revising trades after gate closure. This is confusing for BESS owners and system coordinators, as BESS owners have to submit both bids and offers. There is no reason why there should be different rules for BESS bids and offers. Second, the gate closure period is half an hour for distributed connected generators and 1 hour for grid connected generators. This creates additional alignment issues for embedded BESS because they have half-hour gate closure for their offers but 1 hour gate closure for their bids. We consider it also creates an inefficient incentive to invest in embedded BESS over grid connected BESS, as embedded BESS has the advantage of shorter gate closure. Third, the gate closure arrangements for BESS can lead to conservative trading or frequent offer revisions after gate closure due to the short storage capability of BESS. BESS can typically move from fully empty to fully charged or vice versa in 1 to 2 hours. This can lead to conservative trading due to restrictive rules for revising bids after gate closure or due to BESS owners trying to meet the intent that trade quantities should only infrequently be revised after gate closure. Next slide, please. These charts demonstrate the difference between offering conservatively and offering based on expected outcomes. In this example, the BESS owner is expecting that they won't be dispatched in these trading periods based on their expectations of market prices compared to their bid and offer prices, which indicates prices they are willing to pay or accept to charge or discharge. In the right-hand side chart, the BESS owner is placing bids and offers based on what they expect their state of charge to do. That is, for it to remain the same, as they don't expect it to be dispatched. In the left-hand side chart, the BESS owner is trading conservatively to ensure that they do not need to revise their trades after gate closure. This means they need to consider the worst-case outcomes for state of charge, as indicated by the 2 lines. They are restricting the bid and offer quantities to ensure they can be achieved in these worst-case circumstances. This can be seen by comparing the size of the bid and offer boxes between the left and right-hand charts. We expect BESS owners will make a lot of their profits by taking advantage of unexpected changes in prices during times they didn't expect to operate. This is because they may earn large revenues in relatively rare events, such as after a generator tripping. It is also because prices are likely to frequently vary from expectations in the future, as more solar and wind farms connect to the system. Conservative trading could therefore lead to very inefficient outcomes. Can we just go back to the previous slide briefly? Thank you. There are provisions for offer quantities to be revised after gate closure if the offer exceeds expected capability. Due to their short storage, this can lead to frequent offer revisions if the BESS owner is not trying to meet the intent that quantities should only be revised in rare circumstances. Frequent offer revisions after gate closure can make it difficult for the system operator to assess system security risks and prepare mitigations ahead of dispatch. Finally, we note that different parties have had differing interpretations of how the rules for revising trades after gate closure apply to BESS. Next slide, please. We are proposing that BESS should have the same arrangements when charging and discharging. We consider this would reduce operational costs. We are also proposing that grid-connected and distribution-connected BESS should have the same arrangements. We consider this would improve system security and competition. As we are not intending to reduce the gate closure period for grid-connected BESS at this stage, as described in the following slides, our proposal would mean a 1 hour gate closure for embedded BESS. Because they currently have half-hour gate closure for the generation side, we are considering whether existing BESS and BESS that have reached financial close should instead have 30 minutes gate closure. We are interested to hear stakeholders' views on this in their submissions. Next slide, please. Our longer-term proposal to address gate closure issues of conservative trading, frequent offer revisions, and lack of clarity in the code is to introduce full capacity trading with state of charge constraints and 1 hour gate closure. This would lead to more efficient use of BESS. It would also lead to improved system security because the system operator would have visibility of the range of potential future operating levels of BESS. Next slide, please. So how would state of charge constraints work? State of charge constraints would constrain scheduling and dispatch to what is feasible given the level of stored energy in the battery compared to the maximum and minimum storage limits. Current state of charge would be determined by delimited information that the system operator requires BESS owners to provide. The BESS owner would provide maximum and minimum storage limits as part of their trade form. We are proposing the constraints would be based on availability over 30 minutes for both dispatch and for the forecast schedules. We are, however, interested in hearing stakeholders' views on different ways of determining the assumed operating time for the constraints. For example, whether dispatch should be based on what can be achieved in 5 minutes. That could cause misalignment between the schedules and dispatch, but may better enable BESS to respond to transitory peaks. It could also result in BESS running out of storage partway through a training period. We encourage interested stakeholders to read the consultation paper on this point. We're also proposing that BESS owners provide information in their trade forms to help the system operator calculate round-trip losses. We understand round-trip losses can be around 20%, so it will be particularly important to account for these in calculating state of charge constraints at the longer time horizons in the forecast schedules. We're proposing BESS owners provide a per megawatt number and a static number in their trade form. These could differ for each trading period. We're interested in submissions regarding the best way to provide and incorporate round-trip losses in these calculations, noting that the ability and method of estimating these losses will differ across different BESS owners. Next slide, please. The maximum megawatt quantity a BESS owner could trade would be its power capacity, adjusted for outages, reasonably foreseeable warranty constraints, and any distribution network constraints in the case of embedded BESS. To be clear, by power capacity, we mean the maximum rate of injection or offtake at the grid injection point, assuming sufficient state of charge. In other words, state of charge limitations do not need to be accounted for in this value, as state of charge constraints will deal with that. The maximum megawatt hour max and megawatt hour min values they could offer for use in state of charge calculations would be their physical storage limits after accounting for outages and reasonably foreseeable warranty conditions. However, BESS owners would be able to offer below their maximum limits to control how their assets operate. BESS owners wouldn't be allowed to change their prices after gate closure. BESS owners could only change their quantities and the megawatt hour min and max values after gate closure in rare circumstances. This would include a reasonably unforeseeable breach of a warranty condition. Next slide, please. So because these full capacity trading with state of charge constraints solution would take some time to implement, we're also proposing some interim arrangements. We're proposing trade quantities would have to be no more than their state of charge dependent capability, adjusted to account for reasonably foreseeable warranty conditions. BESS owners would not be able to revise prices after gate closure, and quantities could only be revised if state of charge differed from expectations or in rare circumstances, including reasonably unforeseeable circumstances that would result in a breach of warranty conditions. We consider this proposal would lead to more efficient use of BESSs. It enables similar efficiency benefits to our longer-term proposal, but relies on BESS owners updating their trades after gate closure when state of charge changes, rather than relying on state of charge constraints in the market system. This proposal, however, does not provide the same system security benefits of our longer-term solution, as the system operator would not have the same visibility of the future operation of BESS. Next slide, please. This slide covers two topics that stakeholders asked us to cover in this webinar. First, dispatch compliance. BESS owners would be required to meet dispatch the same as other dispatchable plant. We intend to monitor dispatch compliance and consider whether any additional rules or guidance may be required as BESS operation in the power system evolves over time. Second, what gate closure options are we considering? We have considered various alternative options for dealing with the gate closure issues. These include requiring conservative trading to provide greater certainty for the system operator and reducing the gate closure period for more efficient use of BESS. We have considered reducing gate closure both with our longer-term proposal and with conservative trading. In our view, there may be significant risk to power system security of reducing gate closure as the system operator's tools and processes rely on gate closure. On the other hand, we consider a requirement to trade conservatively would lead to highly inefficient use of BESS. We consider our proposal finds the best balance of system security and market efficiency needs. We have also considered an option of linking offer prices to state of charge, so BESS owners can reflect the opportunity cost of different storage levels. We are seeking views on this option in our consultation paper. If there is sufficient interest, we could investigate the required system operator tool changes before potentially consulting on a code amendment. Next slide, please. We understand that reducing gate closure would bring additional benefits for the efficient use of BESS, as it would enable BESS owners to update their offer prices closer to dispatch time to reflect changing expectations of the opportunity costs of operating their batteries. These expectations could change, for example, due to storage levels differing from expectations because of unexpected dispatch, or due to changes in prices in the forecast schedules. If our proposal is implemented, we would consider further work on reducing gate closure. This work would look at better understanding the risks and benefits. As the system operator's tools and processes rely on gate closure, this work would also consider the costs associated with any required tool and process changes. For example, it may be that the system operator needs to build more conservative transmission constraints to reduce the need to update constraints close to real time. This would create inefficiencies as more low-cost generation would be constrained, leading to higher prices downstream of the constraint. As part of this potential future work, we're considering holding a trial of reduced gate closure. This could help the system operator to better assess system security risks and identify tool and process improvements to enable reduced gate closure. Next slide, please. Yes, I'll just open the floor to any questions. If perhaps Freda could see any questions in the comment section.
Yeah, so we have two questions at the moment from Juliet Glendon. Has there also been consideration for enabling EDBs to dispatch distribution level BESS, e.g. to manage network constraints, or would the TSO exclusively be able to do this? So over to anyone. Yeah, thanks.
That's a good question. So I guess that is a consideration that is part of the future system operator project. So I can't answer that because I guess this webinar is focused just on these two consultations, but we could potentially get you in touch with the people that are working on that project. If you want to email us potentially, what's the best email address?
Yeah, I can throw that in the chat. Yeah, I will find that on the listing for the event that we had. So I'll throw the email in the chat, Juliet. And the second question, Philip Wong 2, will BESS be allowed to deviate from dispatch for periodic operations such as SOC calibration and equalization, where energy quantities to achieve these processes may be uncertain?
Yeah, so again, I guess we'd be keen to understand more about those limitations. If you could provide more information in the submission, that would be really helpful. But I guess at this stage, we know that all BESS owners are going to be different, and I guess it's unclear what the variation from dispatch would be and whether that would cause an issue. So our view is that we could hopefully monitor this as a problem and introduce any guidance or further regulation if it's required, if it turns out to be an issue. But as I say, keen to understand more about the scale of dispatch non-compliance that may cause.
Thank you. Excellent. And just one last question at the moment from Richard Legros. Just following up on Juliet's question and your response, when might you expect the EA FSO roadmap to be published? And he understood that was imminent.
Yeah, I'm not actually sure of that, so I'll find the answer and put it into the chat while the others are talking if I can.
Perfect. Thanks so much, Shelley. No other questions at the moment, so I think we can move on to Hamish.
Hopefully it's going to be Rob next.
Apologies.
Yeah, I'm up. So
Perfect.
The second paper is a consultation on common quality and wholesale market arrangements for BESS hybrid stations. I'm going to be covering the first half of the paper on the common quality requirements, and then I'll hand it over to Hamish to talk about the wholesale market arrangements. Feel free to put questions in the chat as we go, but yeah, just like with the first section, we'll answer the questions at the end. And if we run out of time, we'll take the list away and just provide written answers. So next slide, please, Claudia. So this slide's all about terminology. So historically, the fundamental building block in the code has been the generating unit. But what's increasingly missing for inverter-based and hybrid plant is an intermediate layer between the unit and the station. So this paper therefore introduces a 5-level framework to better reflect how BESS hybrid stations are structured and operated. So in the image there, you can see at the bottom, level 1 would be the generating unit. So this would be things like an individual wind turbine or maybe a synchronous machine. Level 2 generating system, that would be like a string. Level 3 would be the aggregate of all plant of a particular type. So it could be all wind turbine strings grouped together. Level 4 is a generating or a BESS station, and level 5 would be a hybrid generating station. So the intention is to develop a structure that's flexible enough to be applied consistently across the code, rather than just limited to part 8 and 13. Next slide, please, Claudia. So in the common quality section, there are 3 key considerations. The first one is if there's a BESS, if a BESS is charging or discharging, BESS currently has the obligations of a generator. In this paper, we're considering whether obligations should apply while idle. The second point is that we are considering which asset owner performance obligations should apply to BESS hybrid stations across various operating states. And thirdly, the paper proposes clarifying the voltage support requirements in clause 8.23 of the code, by moving the point of compliance from the generating unit terminals to the point of connection with the network. So this proposal would apply across all generating technologies, and it's not limited to just BESS hybrid stations. Next slide, please, Claudia. So a little bit more detail. The first issue is considering how existing asset owner performance obligations, or the AOPOs, should apply to BESS and BESS hybrid stations. But these are the technical performance requirements that support common quality outcomes of the power system, such as frequency and voltage support. So this paper proposes a definition of idle for BESS and hybrid stations. Under the proposed definition, the asset is electrically connected to the network, not injecting or consuming active or reactive power, and not cleared for dispatch in energy or ancillary service markets. The consultation then considers three broad options for obligations while idle. So the first option is full obligations, so that have both frequency and voltage requirements placed on them. Second option is no obligations. And the third option would be partial obligations. So they would be required to comply with either frequency or voltage obligations, but not both. Next slide, please, Claudia. So this one's about obligations for BESS hybrid stations when operating. So the key policy question that we're looking at is whether obligations should apply at the station level or at the individual technology component level. Under a station level approach, obligations would apply at the point of connection to the network. Compliance would not be assessed based on the response of each component within the station. The other option that we're looking at is a component level approach. So under this approach, obligations would apply separately to each technology component within the station. We don't necessarily need the point of compliance to be the same for frequency and voltage obligations. One could be assessed at the station level with the other assessed at the component level, if that would be beneficial. Next slide, please, Claudia. And the last key point on the common quality stuff is voltage support obligations. So the paper considers clarifying the voltage support obligations in clause 8.23 because the existing arrangements were developed when generating plant was generally located close to the grid connection point. Modern plant is increasingly electrically dispersed behind the connection point, particularly for inverter-based generation and hybrid configurations. The proposal would shift the point of compliance from the generating unit terminals to the point of connection on the high voltage side of the transformer. This would better align the obligation with the location from which voltage is actually managed from a power systems perspective. All right, next slide, please, Claudia. And that's me. We'll have questions at the end, but Hamish, over to you.
Thanks very much, Rob. Good afternoon to you and to everybody on the call. Just to reiterate the purpose of this issues and options paper, we, as Claudia mentioned in the beginning, several submitters to the wholesale market arrangements issues and options paper for BESS that was released by the authority back in November 2025, as well as feedback to our BESS roadmap, identified that participants were particularly keen to make sure that we were developing arrangements for BESS hybrid stations alongside those arrangements that we're developing for BESS stations. And so as part of the development of the work that Charlie has spoken about in the earlier half of this webinar, we've also identified several options, and for I guess the purposes of consistency and clarity, we've combined the identification of these options both across the Part 8 asset owner performance obligations realm, as well as the wholesale trading arrangements realm, and the wholesale trading arrangements issues are what I'm going to talk about today. We're also cognizant that at the moment there are no BESS hybrid stations at utility scale at least operating in the market. Certainly, several participants have expressed their interest in developing these types of stations, both in discussions with us and as notified in Transpower's connection queue. And one thing that has come out of the discussions that we have had with potential participants in the development of this paper is overriding desire to maximize flexibility in the trading arrangements. And this is particularly relevant as BESS hybrid stations, given that we do not have much or any operational experience, can conceptually be operated in many different ways. And so one thing that we are anxious to consider when we're developing potential changes to the wholesale trading arrangements is ensuring that we don't inadvertently constrain any potential modes of operation for these new generation types. And so with that in mind, the options that we have proposed within the paper, in section 6 of the paper, are the things that we've identified that would I guess satisfy that criterion, that we're interested to make sure that we are not inadvertently creating rules that would constrain participation. So to that end, the issues that we have identified as pertains to the wholesale trading arrangements, we have 4 of them. So foundationally, we are attempting to establish how a BESS hybrid station should seek to bid and offer their resources into the market. The second option that we have considered, the second issue that we have considered follows on from that first issue in a sort of a development of the options and the concept that we are proposing, which is basically to what degree should dispatch be flexible for a BESS hybrid station. And there are 2 perhaps more technical issues which we have identified as relates directly to DC coupled BESS hybrid stations in particular. And those issues are, we're conscious that there could be particular constraints for injection limits that need to be modeled within the market. And finally, there is an issue that we've identified around how constrained cost calculations would work for DC coupled hybrids. It's possible that participants will have other issues that they want to discuss with us and clarify through potential code amendment. And we definitely encourage all of you to submit those thoughts on any issue, not just the 4 that we've talked about here, in your submissions to this paper. Could I have the next slide, please? So the first issue to confront, as I've said, is quite foundational to considering how BESS hybrid stations would operate within the market, in the wholesale market. And we are of the view that the BESS hybrid stations would best offer within the market by offering by technology component. So if you recall the diagram that Rob spoke to at the beginning of his section of the presentation, which is also found on page 17 of our consultation paper, we're interested in developing the current market offering structure of the market to expand the current, I guess, two-stage or two-level offering arrangements, that being generating unit and generating station, and become a bit more deliberate and a bit more discrete about the levels at which different plant may be able to offer. And in considering our desire to perhaps not deliberately not attempt to create bespoke arrangements for BESS hybrid stations that may be inadvertently constraining, we are looking at the possibility of allowing a BESS hybrid station, when offering by their technology component, offering those technologies in the same way as if those technologies were a standalone station. So for instance, if you had a BESS hybrid station which consisted of some solar generation alongside a BESS, then we would be interested that the BESS hybrid station or BESS hybrid owner could offer the solar station essentially as an intermittent generating station and the BESS as a BESS. There are some particular nuances which we discuss in the paper, which I'd encourage you to go and read the detail on. But to summarize those nuances, there may be some situations for BESS hybrid stations where it just makes sense to offer them as a single station based on the majority technology component of the station. So an example of this would be where a BESS hybrid station consisting of a solar farm and a BESS. If the solar farm was very large and the capacity of the BESS was very small, it may make sense to both the participant and the system operator if the BESS hybrid station was simply offered into the market as a solar station, and the output and injection and offtake of the BESS was not modeled explicitly. We're proposing that this would be subject to agreement with the system operator. Similar provisions exist within the code already for the system operator to require or to require stations which are not otherwise required to offer into the market to have to do so for when their contribution to the market would be necessary for the system operator to meet its principal performance obligations. Another advantage of allowing BESS hybrid stations to offer according to their technology component would be that this automatically enables the BESS hybrid station to participate in the instantaneous reserve and frequency keeping markets, provided that the system operator's requirements are met. Could I go to the next slide, please? So onto the second issue that we have identified. One of the consequences of proposing this concept that we would require BESS hybrid stations to offer per component is that it raises the question of what are the obligations surrounding station dispatch, where there is a potential for one technology component to balance the other. Normally, generating stations are required to follow dispatch within the provisions of the code. The obvious exception to this rule is intermittent generating stations currently are dispatched to whatever their current output is. And so those two examples are essentially poles on a spectrum of the level of compliance that may be applied to a BESS hybrid station. So we were interested in your views, particularly about if you are intending to invest or commission a BESS hybrid station, what are the kinds of operating modes that you would apply, and what is the kind of flexibility that would be desirable within dispatch that may be required to be represented within the rule set. One thing that we have proposed within the paper that makes use of an existing concept within the code is that of a station dispatch group. So you could envisage that if the BESS hybrid station is offering each of its technology components separately to the market, that essentially looks like two generating stations that are working together. And the reason why in that diagram that Rob presented at the start of his presentation had a fifth tier or level on it above that of generating station was trying to capture the idea that within the current provisions we have this concept that many different stations can be operated together. An example of a station dispatch group is Huntly Thermal Station, where several generating units are offered independently, and dispatch compliance would be assessed at the station level. Applying this to a BESS hybrid station would look like each of the components, the technology components that the BESS hybrid station is offering, would be dispatched separately, but the sum of the dispatch could be met by either component in real time if we were to take the current provisions and port them directly to this this application. Comes with some downsides, some technical downsides. So particularly considering the kinds of obligations around state of charge modeling, either for the participant or the system operator that Charlie discussed in the first part of this webinar, station dispatch would make it more difficult for participants or the system operator to predict the future state of charge for batteries that are within hybrid stations that are operating in this way. And so we're interested in participants' views on how this might be mitigated. Can we go to the next slide? So I'll talk briefly about the other two issues that we have identified that pertain directly to DC coupled BESS hybrid stations, and I've included a diagram that we've also included in the consultation paper that describes at a very high level what we mean by DC coupled versus AC coupled hybrid stations, and we've noticed that participants that are interested in developing these plant are quite familiar with these concepts. But essentially, a DC coupled plant has a single connection to the AC network for both or all of the technology components that the BESS hybrid station that the hybrid station consists of. Whereas for AC coupled hybrid stations, each technology component has its separate connection to the grid or to the network. So one of the issues that we've particularly identified is for a DC coupled hybrid station that has a single point of connection to the grid at its inverter, and if the inverter capacity is less than the sum of the potential output of each of its technology components, this actually needs to be modeled within the market in order to preserve secure dispatch. We've presented in our paper 3 options for achieving this, and each option comes with a certain level of technical complexity and involvement on the participant side. The first option that we've proposed is that of a kind of ACS slash outage management kind of relationship where the participant would provide static asset data about their inverter, and this would need to be modeled manually by the system operator and changed from time to time if that limit were to change. A second option is to incorporate the inverter limit within the offer for the BESS hybrid station, which presents some technical complexity but is more dynamic and more likely to not suffer from errors. And the third option is potentially modeling it as a transmission constraint. So we're interested to hear any views on the appropriateness or any difficulties associated with any of those potential options. And the next slide, please. So finally, the final issue that I'd like to present today briefly is that around constrained cost calculation. Constrained costs are very difficult to summarize, I guess. So I'm just going to try and be brief and refer anybody who is interested in this particular issue to our description in the consultation paper. However, if we are to extrapolate the proposal that I mentioned as related to our first issue, the idea that if we had a hybrid station that was offering according to each of its technology components, essentially it is important that when we are calculating constrained costs, that those constrained costs are able to be attributed to each of those technology components within the station. Essentially, each technology component would have its own offers and its own dispatch, and therefore it's important that we assess its opportunity for constrained costs on the basis of each technology component. However, in order to implement this for DC coupled stations, it becomes important to be able to differentiate the metering, the reconciliation data that is injected and taken from the grid by the DC hybrid station between each of its components, and it would require componentry on the DC side of the station in order to make that differentiation. And so there may be some not inconsiderable costs associated with that. We're particularly interested to hear from participants who may have investigated this or have faced this issue in other jurisdictions. If they could provide us with any information that how this has been resolved elsewhere, then that would be very much appreciated. We'd also appreciate anybody's views on whether or not the likely costs of requiring DC metering would justify the benefit of having constrained cost calculations attributed to each technology component. That concludes my part of the webinar. We can now move on to questions again.
Excellent, thank you. So we actually have a question that I think came in at the end of Charlie's presentation. So I can quickly jump back to that just to honour a chronological order, if you like. From Eamon Sullivan, how will parasitic load be treated in the context of dispatch compliance?
Yeah, okay. So basically dispatch is with bids and offers is supposed to be the quantity required at the point of connection to the grid. So theoretically, the BESS owner would be required to meet dispatch after accounting for parasitic load. In our interim proposal, the bid and offer quantities would need to account for parasitic load to make sure sure it's achievable. In our longer term proposal, parasitic load would be required as part of the offer form, incorporated in the losses field to ensure dispatch accounts for that. I guess we also note that there will always be some tolerance in dispatch compliance. And, if, as I said before, if dispatch non-compliance becomes an issue, we would seek to provide further guidance or consult on code changes at that point.
Thank you. So back to the second consultation. Joan Conan asks, can you clarify how or if DC coupled versus AC coupled BESS hybrid projects are being treated differently under the same BESS hybrid station definition, since their interaction with the grid is different?
I think we would probably need a little bit more information about what in particular, which interactions in particular you're interested in looking at. Perhaps an email to the project team is probably the best way to answer that question, I think.
Excellent. Thanks so much, Hamish. Just a couple more at this stage. Philip Wong2 has just asked, are you thinking that the DC metering would be metering grade with data treated the same as any other meter, or would SCADA grade suffice?
We don't have a view yet on what quality requirements there would be for the DC side metering. In fact, even using the word metering might be a bit leading, I suppose. But we're very interested to hear whether there would be significant cost differences between providing, I guess, at one end of the spectrum, SCADA quality data versus metering quality data, or if there are any other intermediate qualities that we could consider, just to be able to, again, inform that cost-benefit analysis.
Thank you. All right, moving on. Ziming Guan has asked, are different technology components in AC coupling connecting to distribution network or to transmission network? The transmission network.
Yeah, I think we are assuming that for AC coupled systems, we would have inverters which are essentially hosting the technology component by itself. So in the solar farm plus BESS example, we are assuming, I guess, that AC coupling, when we're talking about AC coupling, we're talking about a situation where the solar farm has its own point of connection to the network and the BESS has another point of connection to the network. And the relevance of that is that the existing telemetry, metering, dispatch, offering obligations are all centered around that idea of how much energy can you inject into a network and how much energy will you take from the network. So for AC coupling, hybrid stations, all of those existing provisions are, I guess, intuitively applicable. And as we tried to elaborate before, the distinction between the AC coupled system and a DC coupled system, those concepts don't easily transfer to a DC coupled system. That's why we've been at pains to labor the distinction.
Thank you. All right, so Scott Burling has just asked, for AC coupled hybrid BESS, where the grid connection capacity is less than the sum of the BESS and other technology outputs, would it be proposed that this be managed in the same way as DC coupled BESS?
It could be, but it shouldn't be necessary, I don't think. It depends, I think, on the previous issue that was described around the flexibility with dispatch. So that's a concept that I think it would be good to maybe elaborate on in your submission to the paper, and we'll consider it.
Wonderful, thank you. And part question, part comment from Darren O'Neill, which has got a couple of upvotes. Typically, stations would almost always be providing some reactive power to control voltage based on agreed voltage control with EDB or Transpower. This would mean stations are barely ever idle, would suggest that idle is based on the real power, not reactive power. Not sure if you wanted to sort of comment on that, or if Darren wanted to switch on his camera and yeah.
Thanks, Darren. We've noted that, but please put it in your submission too.
Perfect, thank you. So no more questions in the Q&A. This is the final opportunity. Well, not the final opportunity, you can email, but just encouraging you, if you're sitting on a burning question, likely someone else is thinking it. You can also just raise your hand and ask while we're here. We've done well on time, just hit the just over the hour mark, so well done, team. Otherwise, it looks like we're through the questions. So if no one's got anything else to add, we can just move to the closing karakia. Thank you so much, everyone, for your time, and look forward to receiving the submissions by the 30th of June. So I'll just close with the karakia. Kia whakairea te tapu, kia watia e te ara, kia taruki whakataha ai, kia taruki whakataha ai, haumi e, hui e, taiki e. Thanks so much, everyone. Ka kite.